I'm here to give you an overview of open source in AWS. It's an overview talk. It's not going to go super deep in things. We're around if you want to go deeper on any of these topics. Got quite a lot to cover, so we're going to go through it fairly quickly. I did want to just sort of kick off and say thank you to Percona for allowing us to talk here. This is a great conference. It's really a great thing from an AWS perspective that there's an annual get-together of people that care about databases and care about open source. We fit into both of those categories. We're glad to be part of the community and thrilled to be talking. There are a number of other presentations from AWS. I just would draw your attention to them. If you're not aware of them, then please take a look, add them to your agenda, and they're going to go much deeper on many of these topics. So just bring your attention to those. Moving swiftly on. We've been in this sort of cloud business for over 15 years now, and we've learnt a lot. And if you wind the clock back 15 years, to run a database system or to run an application on a database system, you were doing it on-prem. You were having to do all of your own capacity planning, buying the hardware, installing the operating systems, installing the database, paying the license fees, all that good stuff. And then on top of that, having to do all the maintenance and the upgrades and the backups and the restores and all the other things that come with it. And it was a certain kind of set of economics that went with that. You couldn't easily move to a new region. You couldn't easily scale it up or scale it down, and so on. And you know what I'm going to say, which is that, of course, now it's a very different world. Not only have cloud-managed databases radically changed the economics of database management, but they've severely impacted or substantially impacted almost every business on the planet. The ability to be able to be agile with databases, not only to be able to scale elastically and so on, but even to use multiple databases for an application, which historically was very hard to do. Now, most of our using multiple databases within a single application. That's normal. It's relatively easy to do with managed services. And that's really sort of a massive change. And you could say, what's really behind all of that? One of the things that's behind that is, of course, open source. So we pride ourselves on doing 90% of what we do is customer-driven and disciplined customer-driven. So we're very good at hearing what customers want, taking that and turning it into services that they like. And that kind of 90-10 rule is something we take very seriously in AWS. One of the things that they've asked for since 2006 is these open source things that we've been using ourselves to run in our own kind of data centers or on EC2 or whatever, can we have managed versions of that? And so there are over 50 open source technologies that are either provided as services by AWS or a significant aspect of the services that we provide within databases or analytics or AI and ML or elsewhere. Excuse me. So this open source thing, and we'll talk a little bit more about it, is critical to how we think about it. It's critical to what our customers want, and we're very, very involved in it, and increasingly so. We're also very aware that open source software is built by communities of folks that are passionate and enthusiastic and believe in open source and believe that software is best built that way, and we agree with them that you can get enormous value by building things in a sort of a collaborative fashion. And so how do we go about engaging with that? Increasingly, what you're seeing with AWS is that we're listening. We're approaching open source from the perspective of let's make sure that we're engaging, that we're communicating, that we're listening, that we're understanding. Why? Because the community and the customers and the users behind those communities understand where those technologies need to go, and in particular can guide us on how we can help accelerate innovation within open source. And so, this is a sort of a structured idea that we have of how we do this, leading to how do we give back? How do we contribute? Where do we contribute? There are ways of contributing that are not appreciated. There are ways of contributing that are very much appreciated. How can we do that in ways across the board that's valuable to all parties. And again, I think what you're going to see as a pattern is it's not so much about AWS saying, here's some technology that we built and throw it out there and declare it's a new open source project. It's much more about these large numbers that we're trying to work with and help to be more successful and be a constructive contributor. So I'm going to give a couple of examples, some of which are entirely to our benefit and some of which are to the benefit of the community, and just to kind of give you a sense of some of this. So for those of you that know SQL well, you'd be familiar with the merge command in SQL. Roughly what that is the ability to take a sort of a source table and update a target table on the basis of changes in the source table. And so that's being able to do inserts and deletes and updates to that target table based on the content of the source table, and to do that in a single command. This was actually implemented by the folks that are up there, most of whom are from Enterprise DB, and not something that we made a huge amount of contribution to. But what's interesting is this is the sort of example of, because we're running open source, because our customers are wanting open source, this kind of value flows through. And so something which is put into, in this case, Postgres 15, when Postgres 15 gets deployed in the context of Amazon, customers get the value, everyone gets the value from the upstream right through to the customers. And that's a great example of somewhere where we essentially get some value, and obviously our customers do. Here's an example of the opposite. So in this case, Chengyang Wang, who's an AWS person, built an audit plugin for MySQL 8.0, for at least for MariaDB, and so built around the idea of, okay, if we're going to be able to log events, we're going to be able to then provide compliance, we're going to be able to provide debugging and performance management and so forth. And so this is something that's built and delivered on GitHub, typical kind of thing that AWS is contributing to the industry. Excuse me. Redis. Well, Redis 7 has just come out. You may be aware of that. This is the world's most popular database. It's loved by thousands and thousands of people in multiple places. Hugely successful piece of technology. Redis 7 has some great new features, including server-side functions and things like that. Amazon actually has, one of our engineers is on the core committer group, which is a group of 5 people that are really sort of determining the future of the core of Redis. And in the context of Redis 7, some of the things which we contributed are fine-grained access control. Redis is a key value store, so being able to control access to keys and to commands at a fine-grained level is a critical capability. We've added that. Hostname support might sound like a small thing, but you can't really do TLS security without having hostname identity in clusters, and so that's been added. Redis supports pub-sub communications. To be able to partition your pub-sub communications allows you to scale more and control it more. That's been added. Redis supports modules where you can extend more data types or all sorts of new functionality in Redis. What we've done there is to contribute code that allows those modules, the third-party modules, to be configured in the same way that Redis in general is configured. By the way, beyond that, we've been involved in many of the client-side Redis libraries, which are built by independent open source teams, working with them on things like exponential backup and cluster support and other things like that. So again, not that we're kind of putting a new database out there into the open source world, but that we're going in across the board, adding value, adding robustness, adding features, and helping everyone to be successful. So one of the questions, obvious question out there is, so why run open source on AWS? And I've kind of answered this one already. It's really about customers. What we're about is just very, very focused on helping our customers, helping them to be successful, helping them to innovate. And back to this idea of being able to bring upstream technology through and deliver it to customers in a managed service. That's what we like to do. That's what our customers want us to do. And ultimately, part of that is that we need to be helping upstream with the open source projects so that we can achieve that. And we'll go into some more detail about this in a minute. I'm going to change feet slightly and just talk about the broader thing about what AWS customers are looking for. And this might be different from what a lot of the things are that you've sort of, you might be thinking about in the context of open source databases. First of all, that number, 97 zettabytes, I think a zettabyte is like a billion terabytes. So 97 billion terabytes of new data being generated in 2022. That's an IDC number. Okay, that's really get our heads around, I'm sure, but it's a very, very large number. And the point of the slide is that juxtaposition of that as against the other number, which is that in surveys, nearly 70% of customers are saying they can't get the value from the data, or they're not getting the value from the data. That's crazy. So everybody understands data is super important. We're storing it all. We're putting it all sorts of useful places. And we're not getting the value. What's the value they're trying to get? They're trying to get business optimization. They're trying to get decision support. They're trying to get data-driven businesses in general. And so the big picture question for all of us involved in data management is, how do we get customers through this, what we think of as a journey of moving to modern data architectures, but going from there to the point where every person in every cubicle in every company is making every decision based on data. And that data-driven organization doesn't exist yet, or at least, maybe if you look at the numbers slightly differently, 30% of companies are getting there, but the majority are not. So what do we need to do? Basically, it's about having a sort of a data infrastructure that's modernized. I'm going to scoot through these couple of slides because we don't have time to talk about it. But some of the points are obvious. The size of the data is huge. You need scalability and enormous scalability. We've got customers that are certainly running petabytes, even exabytes of data, and so scale is a huge part of it. It needs to be flexible. Nobody really knows what kind of questions you're going to be asking of that data. And so over time, you need to be able to, maybe you've got to do stuff which is operational analytics, maybe you've got to do research analytics, maybe you've got to do stuff which is something very different. It's, you know, what data engines do you need, what infrastructures do you need, what do you need from ML and AI, how does it all fit? You need flexibility. You obviously need security. This data is secure, and security is becoming more and more of a theme, as we all know. Beyond that, governance is super important. You've got to be able to demonstrate that that data hasn't been touched by certain people or has been touched by certain people. You've got to be able to manage the security. You've got to be able to manage all of those things in a well-governed kind of a fashion. So data governance is becoming super important as part of this journey that these customers are on. Availability, it doesn't help to have infrastructure that goes away every now and then or goes away most of the time or whatever. You need that availability. You need that total reliability of these systems in order to be able to drive 24-hour businesses. And if it's not cost effective, you can't afford it anyway. So building a modern data strategy is really sort of a big, wide, grand kind of a thing that we all need to be kind of working on. And AWS thinks about it as a kind of a journey. And we think of it, and you can like or dislike the terms, but we talk about modernize and unify and innovate. And different customers are at different points in that process. Modernize you can think of as getting to cloud-style database management, because once you get there, you get all sorts of immediate elasticity benefits and so forth that we're all very aware of. Beyond that, unification, and we'll go into this in a bit more detail as we talk about some of the products. Unification is really about getting to the point where your data is all accessible and where you can start doing database decision making and data-driven business stuff. And innovate is principally about, okay, if you've got all of that, how do you start now applying ML and AI and next generation technologies to drive this forward? So that's the sort of overall, if you like, journey. And I'm going to talk really through the rest of this about each of these and try and scoot through some of the things that we've been doing around each kind of product area. Hope that makes sense. Excuse me. On the first part, which is modernize, people sometimes say to us, gee, you seem to have a lot of databases, and the answer is yes, we're proud of it, that we have what we call purpose-built databases, and you see the list up there. if coming from the direction that we are in this room, you can look at that and say, well, where's the Cassandra one? Oh, that's the wide column database on the right. That's called Keyspaces. Where's the Mongo one? That's the DocumentDB, which is the green one in the middle, and so on. Where's the Redis database? Actually, there are two of them. That's the caching, Elasticache, and MemoryDB, which is the durable Redis engine, and so on. And then, of course, on the left, you see the relational engines, which is obviously Postgres, MySQL, MariaDB. By the way, within RDS, we also support Oracle and SQL Server, which we won't include in the open source part of it. But essentially what you're seeing here, even when you look at something like Neptune, which is a graph database, supports the open APIs. It supports Gremlin, it supports Sparkle. It now also supports OpenCipher. And so that's very much what we're doing, is we're saying we want people to be able to run their workloads that they're running elsewhere, to be able to move them to the cloud and get all these benefits of scalability, elasticity, security, and so on. So that's the sort of purpose-built part of it. And what I'm going to do is just go through some of these services and tell you what we've been doing in them. Again, we're short on time, so I'm going to sort of move through fairly quickly. RDS is the original relational database service on the open source side. As I've said, that supports Postgres, it supports MariaDB, it supports MySQL. And it allows you to take your existing workloads that run on those databases and run them in a managed service. And we take care of all the undifferentiated heavy lifting, as we call it. And we strive there to be, there's obviously added value as well. We have multi-AZ durability and so on. But to a first approximation, this is 100% open source code. Your code should just run. As I talk through what we've been doing on RDS, I wanted to just kind of say a little bit of a boast, which is Gartner just came out a couple of weeks ago with this, what they call their solution scorecard for operational databases. And this is the world record for DB Pass, as they call it, which is database as a service, which is 95% on their scorecard. No one's ever done that before. So I think what we're talking about here is RDS. Actually, this does include both RDS and Aurora in this analysis. But it's really it's a very capable service. So a couple of things. Talk about some new things that are now available. RDS multi-AZ, which means basically that you can now have two replicas of your RDS database. That gives you both, obviously, great ability to fail over. It gives you more capacity on reads, and also, by the way, reduces your commit latencies. So that's a big piece in RDS that came out recently. Support for version 10.6 of MariaDB. If you're familiar with the latest versions of MariaDB, I won't need to tell you what all the features are. They're listed there. Support for the MyRock storage engine and so on. Delayed replications allows you to trade off latency for replication delay. And atomic DDL, that's the ability to do things like create table in a crash-safe kind of a fashion. So that's what's coming out there. The last item on this slide is AWS controllers for Kubernetes, or ACK. This is open source technology which allows you to control various AWS services from within Kubernetes. And you'll see there's some more of that to come. ACK is kind of one of the easy ways for people that are in the world of microservices and containers and Kubernetes and so forth to be able to manage AWS services. So Aurora is also a relational database service, really based on both Postgres and MySQL. This was driven by the requirement from customers to say, we're really moving the biggest relational engines that are out there. We want open source, but we want open source that gives us similar qualities of service, similar performance, and so forth to those engines. And so that's what you're looking at here in our performance measures. Aurora can do like 5x the performance of MySQL, 3x the performance of Postgres, and it does it at 1/10 of the price of the commercial engines. It also gives you multi-AZ durability. It stores things 6 times in 3 AZs. So super, super secure for your data. And that's what that's all about. I think you're probably familiar with Aurora. It's still one of the fastest growing services in AWS, by the way. We just shipped serverless for Aurora. So serverless is a big deal across multiple of our services. What does this mean? It means that it's an option, it's not a replacement, but you can go to the console, and instead of telling us what instances you want, you simply say, I want to be serverless. In that case, you don't have to do any provisioning of instances, you don't have to do any scaling of instances. We take care of all that stuff, and you just use it. You've basically got an API, and you call the API. Secondly, Babelfish. So what's Babelfish? Babelfish is a translation layer that sits on top of Aurora Postgres that listens for Microsoft SQL Server network protocol. It also translates Microsoft SQL into Aurora SQL. And that allows you to run essentially a largely unchanged Microsoft SQL Server application against Aurora Postgres. This is typically used as a migration path to native Postgres. And so, because it allows you to then run workloads that are Microsoft-oriented as well as workloads that are Postgres-oriented against the same data in the same engine. So Babelfish is out there today. DevOps Guru is fun. This is using ML technology to track, to monitor what's going on and to basically make decisions, tell you about optimizations, find bottlenecks in your system based on patterns that have been seen elsewhere. Again, we run at quite large scale, as I'm sure you're aware. I think the latest numbers of our kind of database migration service, the number of databases that have migrated through DMS to AWS are over 640,000 databases. So and that's by the way, that's a fraction of the total number of databases, but just to give you a sense of the scale. So we've got very, very large there, and DevOps Guru is able to use ML to take some of that information and those patterns and apply them to your systems at whatever scale you're running at. MemoryDB is an interesting, sorry, yeah.
Is that a paid service, the DevOps Guru?
Yeah.
So
Yeah. MemoryDB is 100% Redis compatible. It is actually Redis, but the difference between this and Redis is that it's got rigorous back-end durability. So it's got all writes are transactionally committed to a multi-AZ transaction log. So you've got 3 AZ durability on all writes, but it still has all the benefits of Redis, which is this API that's loved by everybody, and performance which is crazy. So you can do sub-millisecond reads, writes which are a few milliseconds, and with all the other cool stuff that Redis gives you. So that's what what MemoryDB is all about. The latest news on MemoryDB is that it's another service that is now supported by ACK. This is actually in preview. It's not in GA yet. Will be in GA soon. But once again, in fact, what we're finding is Redis is extremely popular in the kind of microservices world, and MemoryDB is attractive because you don't have to have a separate cache with some other database in the background. You can just go straight to MemoryDB. It's fully durable. It can be your database of record. DocumentDB, of course, which is MongoDB compatible. It's not the MongoDB source code behind the scenes. We actually redesigned it so that it's actually got independently scalable storage and compute, and it gives you lots of great things, like it can scale up to 664 terabytes without sharding. It can scale at the compute layer independently, of course, of the storage layer. And designed really for the fact that many of these MongoDB workloads are becoming much more enterprisey, and so people are putting much more valuable data into JSON native databases, and expecting kind of performance and security and durability and availability and things like that at levels that are typical for enterprises. That's what DocumentDB is all about. Briefly, DocumentDB's now got in preview performance insights, which allows you to drill into the database and find out what's going on under the surface, and by doing that, to figure out what you need to do to improve performance or address any kind of concerns that you have. Region availability, so it's been deployed in China and in Milan, and of course we're quite pleased that it's out there now with a free trial. So anybody that wants can get 750 hours on a T3 medium for free to check whether it in fact does what you hope it does with your existing application. Neptune is our graph database, and so you're probably familiar with that. It's good. It's used typically for identity graphs and for fraud graphs, for knowledge graphs, and other things. It has historically supported historically supported Gremlin and Sparkle, and now, in addition, supports Cypher, which is the language that's typically you would use if you were using Neo4j, for example. OpenCypher has a good chance of becoming an industry standard. That's now supported directly in Neptune, and a free trial, which is very much along the same lines as the DocumentDB free trial that we talked about. The Cassandra compatible database, which is Keyspaces, it is Cassandra compatible. It has some significant advantages. It has the ability to scale to huge workloads without affecting its throughput or latency, and so it's got a sort of an enormous scalability capability to it. And a lot of our customers in the Cassandra world are running very big workloads. Cassandra's one of the more challenging database systems to run yourself, and so particularly at those huge scales. And so it now has a support for the Spark Cassandra connector. So Spark, you can use Spark to access data that's directly in Keyspaces, and it also now supports the AWS SDK. So I'm trying to kind of move quickly here. We talked about modernize, and that's really sort of think about it as that array of different databases and all the things that we're doing, most of them open source related things. But in some ways even more open sourcey is the kind of stuff about how do we think about unify. And here we also have a list of services, which again you're probably familiar with. And so whether it's EMR, which is running the classic kind of big data kinds of things, which might be Spark or might be Presto or something like that. Athena, of course, is Presto based. OpenSearch, which is the kind of open distribution of Elasticsearch. So again, open source. Amazon Kinesis, which Amazon Kinesis and in fact MKS, which are Kafka style things, and Glue, which is our general integration thing, which is probably a little bit more complex. So you can see that there's kind of a wide range of analytics services, and they're typically used in this sort of next part of the journey where people are already running their databases on AWS, and what do I do with my data? Where do I put it? How do I put it into a data lake? How do I analyze it in that data lake? And again, we're working hard to make sure that we're working with open source community to build the tools that people need to analyze that data. So EMR, we kind of briefly discussed it already. It is open source based, Spark, Hive, Presto, and other analytics engines that you can run within EMR. It does have optimizations. We can do a lot of the work that you would normally do in open source versions at kind of 2x the performance. That's a typical kind of a thing. And so, but that's what EMR is all about, managing those somewhat complex kinds of environments. What's new in EMR? Serverless. So I mentioned earlier that serverless is one of the themes. That's quite challenging. Some of these kinds of EMR jobs are much more episodic than you would see with a typical database deployment. And so being able to be serverless on that is valuable. Secondly, let's just jump to Athena. So Athena, think of it as kind of Presto-based. This is like accessing your data where it is the way to think about Athena. So you're putting your data into S3 buckets, whatever, or indeed it's leaving it where it is in your existing database engines. How do you write SQL queries that can access all that data wherever it happens to be? That's what Athena is all about. And so very much again a big growth area for us. And the news really on Athena is very simple, just a lot more data connectors. So basically when you think of this as the universal way to get at lots of different things, this includes connectors, by the way, on other cloud providers. So you can use Athena to access data that you've got stored on Azure or GCP or something like that. OpenSearch. So OpenSearch is based on Elasticsearch, as I think you're aware. It's based on the sort of the Apache 2 licensed version of Elasticsearch, but is out there as a project, as we'll talk about in a minute, as an open source initiative. It's a service, however, in Amazon, so Amazon OpenSearch, and again, one of our fast-growing and successful services. In terms of news on OpenSearch, really just that we have a new interface for log analytics and for visualization of OpenSearch activities. So that's kind of the main news there. OpenSearch itself as the independent project is out there. As I mentioned, it's based on Elasticsearch. It's really it's an interesting thing because from our perspective, I know this is an example of us feeling that we really want the sort of open source piece of this to succeed, and being prepared to put quite a lot of energy in behind it. You can go to opensearch.org and find out more about what's going on in that world. The news from that project is really the 2.0, and so again, these are sort of specific document level alerts, document level security, things like that are happening in OpenSearch. So again, MSK, if you're familiar with MSK, this is kind of managed streaming for Kafka. That's what MSK stands for. So if you're used to running Kafka workloads, then this is a managed version of Kafka. And a little bit like RDS, the intent with MSK is for it to be running pretty much the most recent versions of Kafka that it can, with most of the features that are available in open source, and to make it easy for people to move Kafka workloads to Amazon. So that's basically what it's about, and really it sort of has all of the usual AWS security and so forth that you get as benefits, but beyond that, largely it's open source Kafka. And again, what's the news there is serverless, and so you're seeing a trend here. A lot of these services that we historically would have said, well, what you really want is to have an open source project as a managed service. Now, what you're seeing is a lot of these services appearing as serverless managed services, which is where a lot of customers are wanting to go. And so the benefits that you get are, as described here, just ease of use, simplicity, and not having to manage the complexity of it all. One of the things about serverless I should mention on all of these cases is that without that, it's quite common for people to over-provision. And so when you see us talk about these services being cost-effective, what we're doing is we're building them so that customers can save money, and they can save money by not using, or at least not paying for resources that are not being used. So serverless allows us behind the scenes to do all sorts of optimizations, including, as I say, making sure that we're not over-provisioning, but also allows us to sort of optimize exactly how we deploy those workloads, and we're not constrained by anything else. We can simply do what we need to do to give you the service that you need. So cost effectiveness, when you think about serverless, it's sort of easy to think about the sort of the ease of it and the simplicity of it and so forth. A big part of it actually is that it gets people to pay for what they're really using. Glue is our data integration service, and so it's quite complex. There's lots of pieces to it, but it's all of the things that you might think of as kind of ETL and so forth. are part of Glue. And so this is really sort of, and when we talk about unifying, there's unifying at the data lake level, and that's a lot about kind of data lakes and S3 and all of those kinds of things, and then using Athena and EMR and tools like that. But there's also integration at the kind of operational database level, and Glue is a lot about that, is that if you're wanting to get engines to talk to each other that are database engines, Glue is part of that. We announced Glue Elastic Views a few months back, which is the ability to have materialized views from one database in another database. And so, Glue is really about those kinds of technologies at that kind of level. It's not about the data lake level, and it's not about, if you like, the presentation layer of the data. It's about integrating at a database level. And so sensitive data detection is new in Glue. As I mentioned earlier, security is becoming more and more important to people. PII data is becoming important to people. GDPR and all the other sorts of compliance requirements. And the ability for a data integration tool to detect as part of the pipeline that something is sensitive data, and then to be able to take action on that is critical. And so that's available in GA today. Auto-scaling. So auto-scaling is, again, if you imagine a pipeline of sort of ETL-like jobs, there are different stages in that pipeline, and you want to have them have matched capacity. Trying to match that capacity yourself as a user is less fun than an auto-scaling system that can do that for you. And again, that gives you cost benefits, that gives you performance benefits, and so forth. And then lastly, the just interactive sessions with Glue, the ability to run notebook jobs, if you like, quickly without having to wait for an entire pipeline to come up, which can take minutes, is basically what that one's all about. So as it says here, time to first query in seconds is the key there. And that just is a sort of productivity improvement thing for people that are doing that kind of work. So we've sort of talked about the whole area of kind of, if you like, modernization, what we call modernization, which is about the array of different databases that we have and the things that we've been doing around that. We've talked about the whole kind of unification side of things, which is a lot about what you might think of analytics and data lakes and integration types of things. And what I wanted to just kind of jump onto in the amount of time that we've got left here is to just talk about ML and AI, which is the innovate part of it. And here there's probably less, I shouldn't say less, the open source pieces of it are most valuable at the bottom of this stack, is probably the way to say it. So when we think about ML and AI, there's this sort of, and at the bottom is ML frameworks and libraries and hardware and things of that sort. And the middle layer is really about kind of the kind of ML model building, kind of process and pipelines and so forth. And so that's not so much about programming, but it's about kind of models being the key and developing your own models. And AI services are about solutions that are at a higher level. And so if we jump into that, you'll see, and I don't have I'm not, sorry? Was there a question? No. We're not going to drill into the details of all of these. I just wanted to show you these couple of slides to give you a sense of what's going on here, in case people do want to follow up. And so what you see at the bottom layer in terms of ML frameworks, there's a lot of things that you're familiar with, the kind of stuff on the left here, the libraries that you're familiar with, and technologies that you're very familiar with, like EC2 and so forth. But it does include things like Inferentia, which is our dedicated kind of inference processor, or Trainium, which is our dedicated training processor. There's a whole lot of things that are part of this kind of toolkit, and if you're a sort of a toolkit kind of person wanting to build, ML and AI systems from the ground up, this is your entry point. These things are available. You can go do whatever you want and have fun. We intend to have the best infrastructure available for you to be able to go and do that stuff. At the next level up is if you're looking for a brand name, it's SageMaker, right? This is the ability to build models without having to be a sort of a core programmer or anything. You might be trying to solve some kind of custom ML kind of problems. And what you've got here is the workbenches, the CI/CD pipelines, everything that you need to be able to pull together models of your own to be able to analyze your data and put that into production. So lots of good stuff at that kind of level, and again, a lot of detail that we could go into. Once again, at the bottom here is much more of the kind of the open source aspects of this, and then at the top, at the sort of the I apologize, the slides are a bit kind of screwed up, but I think you can read it. Basically, if you've got an application that needs to include vision, we have that for you. You don't have to go and build your own models. You don't have to worry about all the stuff at the bottom of the stack. You can just use it. If you've got an application that needs to do natural language processing, those features are there. You can go use them. We've got actual services that directly use that. You're familiar with Alexa and other Amazon products. They obviously include a lot of these kinds of technologies at the top of the stack. So when we think about this end-to-end kind of conversation of customers modernizing and then unifying and then innovating, a lot of the innovation is really at this end. Once you've got that data in a place where you can get at it, where you can use it, where you can feed it into ML-based systems, where you can train those systems, and when you can start applying those back into your operations, that's when you start getting that leverage. If you remember that very first slide that we talked about, that there are these 97 zettabytes of data that's being stored, and only 30% of customers that are actually using it. Ultimately, this is the holy grail. This is where we want people to be getting to, is to be able to take that data and do this. So that's really all I had. I think that just the overall message is that we're here to deliver every kind of app and for every kind of data. Very aware that our technologies are based on open source, that our customers want them to be based on open source, that as a consequence, we're here to work with the open source communities across the board. We're not perfect at it. We're getting better at it, and we intend to get better at it. And that's really sort of all I had. I wanted to leave a few minutes at least for some questions if people have any. Excellent. That's perfect. Answered all the questions already, or? Great. All right, that's all I have. Thanks very much, everybody.